In this lesson, we're going to be talking about assembly basics. Assembly language is a very low-level language that's really almost a direct translation between the machine code and the assembly language. Let me show you what I mean. I'm going to show you an assembly language program. And it's not a very impressive assembly language program. Where it says section, I'll explain those shortly. What we've got here is an opcode or an operation code. And then after that is the register. And then here is actually a reference to a point in memory. When you use assembly language, this mnemonic is really just a way of doing something that's human readable, and it really directly translates to an opcode. There is an actual opcode that is the move operation for your particular processor. Now, this register here is a chunk of memory that sits inside the CPU. It's very fast, and it's how the CPU actually handles manipulation of data is using the registers. The registers also give us access to things like telling the processor which types of things to do. For example, what I'm doing here is I'm actually executing a print. And so I've moved some data into some registers, and moving into register EAX, the number 4, what I'm really executing is the system print utility. I have loaded up the data that I want to print out, and now I have loaded up the actual system call here, or the syscall, and now I'm calling the kernel. That's the int0x80. That says execute the system call that's in EAX and use the data that's in the other registers as necessary to actually run that system call. This is actually the data, and what I've done down here is I've loaded up the return code and then the syscall for the exit routine. So this actually exits the program that we've got here. There are 2 sections in this particular program. The first section here, the .text section of any program, is where the actual executable code resides. And we have to tell the program here where everything lives. And when you're using a compiled program, your compiler would actually do this for you. But what we've done here is we've said this is the text segment here, everything after the .text section. And this right here says, what you want to do once we've entered the text section is go to this label that says _start. This is actually where we are going to begin executing the code. Down here is the data section, and that's where we store, not surprisingly, data for the program. And you can see we've got the message, and that's a byte array here. And the length is actually a reference to how long the message byte array actually is. We've got a length and we've got a message, and what I would do would be to actually run the assembler against this. And I'm going to say that it's an ELF output, and the ELF is the particular type of file format that Linux runs. And now I need to do the linking here. I'm going to say hello.o, and I want my output to just be hello. Now I'm going to say .hello, and it says hello world. This is really just a very brief overview of assembly language. This is using Intel's assembly language. Every processor actually has a different language because they have different opcodes. If you're really interested in assembly language and you want to understand it without having to deal with some of the complexities of the Intel assembly language, you could actually learn the MIPS assembly language. And there's a really good emulator called SPIM, which will emulate the MIPS assembly language. It's a much smaller set of operations, and you can get a pretty good handle on how assembly works and how you would actually code in it using SPIM. And once you're ready, then you could maybe tackle the complexities of the Intel assembly language.